Hello viewers, you are welcome to my YouTube channel. Today's video is about a diagrammatic representation or a system architecture of a UPS solar system automatic changeover. Let's explain about the function of each of the components in the diagram. So this diagram is about the automatic changeover, how the switching from the main power supply to the supply by the UPS takes place in the building, because with UPS there must be an external source of power supply, since the UPS serves as a backup power supply. So what I want to explain in this diagram is how the two power supplies, that is the main or the external power supply, and then the power supply from the AC output of the UPS, how they've been connected for an automatic changeover or switchover in case of a power cut from the main, that is the external source of the power. How the changeover takes place with the main and the UPS in case of a power cut from the main. So as you can see in this diagram, this is the meter. The meter is the external source of power supply in that building. Then a circuit breaker, a double pole circuit breaker, as a safety device being connected from the meter. It goes to the consumer unit or the bus bar consumer unit. It is also known as the bus bar distribution box, because it is the box that distributes the power from the source, that's the meter, to every apartment or every room in that building. As you can see, we have room 1, room 2, and room 3. So it is called the bus bar consumer unit or distribution box, because it has two bus bars, which is the positive one and the negative one. The red and the black represent the positive bus bar and the negative bus bar. And in this case, it is a single phase bus bar, since the positive bus bar is 1. But when you have two positive bus bars, it means it is a double phase, two positive bus bars or three positive bus bars, meaning it is a double phase or triple phase. So, but in this diagram, it is a single phase bus bar. So, you have the inverter or the UPS. It serves as the backup power supply in the absence of the main power supply. It takes over in supplying the power to the building. So, it is the UPS because it works as an inverter and also works as a charger. It has an inbuilt uh, charger that charges the battery with the power from the main supply or the external source of power. So it uses the power from the main supply or the external to charge the battery. And the inverter is being used in converting AC current from the battery into AC current to supply to the building in case of a power cut from the main. That is why it is called the UPS. It has both the inverter and the charger. This is the AC output. The AC output goes to the consumer unit and is connected in the consumer unit. So what happens in the consumer unit is that it is a closed loop in which the external power supply and the power supply from the inverter meets in the consumer unit. They all are connected in the consumer unit. So the changeover takes place automatically because it is a closed loop. So you also have the AC input. The AC input also comes from the consumer unit, the bus bar consumer unit. I will explain it later. And you have the battery. It is a 12 volt DC battery being charged by the UPS when there's a power from the main or external source. The UPS is a 12 volt UPS. The same thing with the voltage of the battery. The voltage must correspond, it must be the same since we are connecting the inverter directly to the battery. So they must have the same voltage. If not, there'll be a problem. So you have to take note of that. The voltage of the inverter and the voltage of the battery must be the same since you are connecting them directly. So let's explain about how the automatic changeover takes place because that is the topic of this video. So as you can see, the main power supply goes to the control unit, consumer unit, and also the AC input of the inverter is connected to the consumer unit for the charging of the battery. The AC input is the AC supply. What supplies the AC current to the inverter from the consumer unit for the charging of the battery. As you can see, it is connected. The AC input is connected. The positive of the AC input is connected with one of the miniatures, that is the circuit breaker. It is connected with the miniature or circuit breaker that supplies the power to room 1. That supplies the power to room 1. So the AC input of the inverter is connected to the circuit breaker or the miniature that supplies the power to room 1. So meaning it gets the power from the circuit breaker of room 1. That is the positive wire of the AC input. of the inverter. Then the negative wire is connected to the negative bus bar of the consumer unit. So meaning whenever there's power from the main or the external source, the AC input of the inverter gets the power to charge the battery. So it gets the power from the circuit breaker or the miniature of room 1 to charge the battery. The positive bus bar supplies the current to all the miniatures. We have 3 miniatures or circuit breaker connected to the positive bus bar. So they supply the positive current, that is the light current, to room 1, room 2, and room 3 from the main. That is how the arrangement is. So the AC input of the inverter being connected to the miniature of room 1 gets the power to charge the battery. Then the AC output of the inverter, that is the one that supplies the AC current to room 2 and room 3. Because the AC current is only connected to room 2, the AC current of the inverter is only connected to room 2 and room 3, as you can see in the diagram. So it supplies the current to only room 2 and room 3 whenever there is a power cut from the main. So the inverter or the UPS serves as a backup. So in that backup, it supplies the AC current to room 2 and room 3. That is why you are seeing it is connected. It is connected to the circuit breaker or the miniature of room 2 and room 3. But there's something very seriously to take note with the diagram. For the connection of the AC output of the inverter to room 2 and room 3 of the building. Since you are connecting the AC output of the inverter to room 2 and room 3, meaning you must turn off or switch off the circuit breakers of room 2 and room 3 to disconnect the power supply of the positive from the main. That's from the meter or main power supply. So that only the power supply of the EPS would so that only the power supply of the EPS will be supplying the power to room 2 and room 3. So it is advisable for safety reasons you turn off the circuit breaker of room 2 and room 3 to disconnect the power supply from the main with that of the EPS, so that only that of the EPS can be supplying to room 2 and room 3. So the positive bus bar is connected to the positive bus bar is connected with the positive power supply from the main or the meter, and by extension it supplies the power to all the miniatures in the building. And that is why I'm telling you, or it's advisable to turn off the circuit breaker of room 2 and room 3 so that only the AC current for power supply from the inverter will supply room 2 and room 3. Or the other way, you are to disconnect the connection, that's the wires of room 2 and room 3 with the miniatures or with the circuit breaker, and only connect them with the AC output of the inverter. That's another way. If you don't want to leave the connection the way it is in the diagram and turn off the switch of the miniatures or circuit breaker of room 2 and room 3, then you disconnect the wires that are coming from room 2 and room 3 with the circuit breakers of room 2 and room 3. So, and then the negative of the AC output goes to the negative and positive. So all the negatives in that building goes to the negative and positive. So as you can see in this arrangement, by so doing, you get your uninterrupted power supply because you are using both the main power supply and the UPS in one consumer unit. So the switch over takes place automatically. Whenever there is the main power supply, it supplies to room 1 and also to the input of the UPS in that building, because room 1 is connected to the main power supply directly via or through the miniature circuit breaker. But room 2 and room 3 are connected to the AC output of the UPS. So the main power supply from the meter supplies to room 1 and then the AC input of the inverter. So in the absence of the main power supply, the UPS takes over since it serves as a backup by supplying the AC power to room 2 and room 3 in the building. And with this arrangement, with this connection, it happens automatically because you may leave the button of the UPS on. It can be on. Leave it on all the time. Unless if you want to go out, unless if you want to leave the building. But whenever you are around, you may leave the button of the UPS on. Switch the button of the UPS on so that when there's a power cut from the main, the UPS continues with the power supply to room 2 and room 3 automatically, because it's gonna happen automatically. That is the switch over. So this is how it works. Thank you very much for listening. Thank you for liking. Thank you for subscribing, and watch out for more videos or more content. Thank you very much.